Hi everyone, this is Miss Faina. Today we're going to be talking about systems of equations. We're going to be looking at tables, sets of ordered pairs, and graphs. So a systems of equations is two or more equations. Okay, so when we're given a table, what we're looking for is a common point. So if I look at this table, notice that this first table, I have the 0.13, and on the second table, I also have the 0.13. That would be known as the solution of the systems. Okay, so in a set of ordered pairs, we're doing the exact same thing. So again, I'm looking for the same point. I notice this first one, I have 2, 5. This second one, I have 2, 5. That would be the solution to this system. Okay, now when we're given a graph, the point in common is going to be where the graphs intersect. So they intersect right here. That point would be 2, 1. Okay, so again, we're just looking for the point of intersection or the point that the either two tables or list of ordered pairs have in common. So the blank is a point that is in common to both tables, both lists of ordered pairs, or both graphs. That is going to be the solution. Okay, so we have some examples. We're going to go through and find the solution. Okay, so we have, let's see, this first table, we have 0, 1, 1, 3, 2, 5, 3, 7. The next table, I have 1, 3. I had that in this one. So the solution for this is going to be 1, 3. Okay, looking at the second one, again, I'm looking for the points that they have in common. So if I look, I have 0, -1. The second table does not have 0 as an x value. I have 1, 2. Well, this one goes 1, 3. I have 2, 5, and 2, 5. So that looks like they're the same, which makes that my solution. Okay, looking at this third table, I have 0, 2. Okay, which in this one it goes with 0, 6, so those don't work. I have 1, 7. This one goes with 1, 9. I have 2, 12. Well, this one doesn't have a 2, so I'm going to extend that table. So if I add 1 here, okay, because the pattern with the x's was adding 1. Okay, that would give me the 2. To go from 0 to 3, I added 3. 3 to 6, I added 3. And 6 to 9, I added 3. So on this side, to get the next y value, I'm going to add 3. So 9 plus 3 is 12. And that gives me the same point. So I have 2, 12, and 2, 12. So sometimes you may have to extend the table if it's not given to you. Okay, so remember the solution is the blank that the two sets of tables have in common. It is the, let's say, point. Okay, because all of those are points. Okay, moving on to ordered pairs. So again, we're just looking for them to have the same ordered pairs in each set. So in this first red one, I notice that I have 2, 5 in common. That would be the solution. Okay, looking at the second one, it looks like it is the 0.13. I have that in both groups, so that would be my solution. And the third one, the green one, I have, let's see, 2, 12. 2, 12. Okay. So the solution is the blank that they have in common. It's going to be the ordered pair. Okay, just know ordered pair, point, they mean the same thing. Okay, it's just different ways of saying it. Okay, now we have graphs. Let's look at the graphs. Remember when we're doing graphs, we're looking for the point of intersection. Where do the two lines cross or intersect? So looking here on the blue graph, they intersect right here, and I just have to be able to label the point. Remember, x's go first, y's go second. So I go over positive 3, down 1. So the solution was 3, negative 1. Okay, on the purple graph, again, the point of intersection. This time I go over 3, but I go up 1, so that point of intersection is 3, positive 1. Looking at the green graphs, I have a point of intersection right here. That is negative 3, positive 2. And the solution is where the lines intersect, which means cross. Okay, where the lines are crossing. Okay, now we have some different types of solutions. So looking at this, think to yourself about this first graph. What do you think is happening? If the two lines are parallel, okay, that means they never intersect. So if they never intersect, that means there is no solution. So never intersect, which means there is no solution because they are parallel lines. Okay, looking at the next one, these intersect at one point. Okay, so one point of intersection. Okay, so it's just going to have one solution, and it's whatever that number is. So negative 1, positive 1. Okay, now looking at this last graph, okay, notice that they're the exact same line. So the first line is right here, the longer line, and then the second line, okay, is this shorter one, but it's the exact same line. They're going to both keep going forever and ever and ever. These are the same line, which means every point is going to intersect with the other line. This means there are infinitely many solutions. So I'm going to abbreviate infinitely many solutions. Okay, so that would be the answer we're looking for here. So you have 3 different types of options. You have no solution. That's when you have 2 parallel lines. You have one solution where the lines intersect at just one point. And you have infinitely many solutions where they intersect at every single point on the line. So the solution is where the lines again intersect. Okay. So to find a solution to a system of equations, I will look for the point in common. Okay, whether it's a table, a list of ordered pairs, or a graph, you're looking for which point both sets of data have in common. Okay, so if you have any questions, please reach out to your teacher. We're here to help you. Other than that, have a great day, Rangers.